So this is a short video lesson on factoring using GCFs. The first thing that you have to remember whenever you're factoring out a greatest common factor is you have to remember what a factor is. So when I have two numbers that are multiplied to each other, they both represent factors. And when I take their product, which means multiplying them, when I take a factor times a factor, that's equal to a multiple. So when we look at finding greatest common factors, we're looking for the largest number that two multiples share, and that would be the greatest common factor. So when I look, for example, at 10 and at 6, obviously I could have 1 times 10. I also could have 2 times 5. That's a set of all different factors that multiply to 10. 6 has 1 and 6, and also has 2 and 3. So when I look at the list of factors for those two multiples, the only number that they have in common is the number 2. Well, 1 and 2, right? They both have 1, they both have 2. 2 is larger than 1, therefore 2 is the greatest common factor of 10 and 6. Same thing works for 12 and 6. When I look at all their factors, I have 1 and 12, I have 2 and 6, I have 3 and 4. Here I also have, for 16, I have 1 and 16, I have 2 and 8, and I have 4 and 4. If you're ever wondering if a possible number is a factor of a multiple, always take a multiple, or the number that you have, and if you divide it by the possible factor, right, you don't know if it is or not, when you take that division, if it comes out to an integer, like 1, 2, 3, 5, 10, whatever, an integer, then you know that the thing that you divided by is a factor of the multiple. So when I look at this list, obviously I see lots of numbers that they share. They share 1, they share 2, they share 4, but 4 is the largest factor that they share, so that is my greatest common factor. As you get better at this, you can start picking out numbers a little quicker. 15 is going to break down into 3 and 5. 18 breaks down into 3 and 6, 3 times 6. And here, since 5 and 6 don't share any common factors, I can just go ahead and say 3 is my GCF, or greatest common factor. Now sometimes they give you problems when there's variables too. So the number process stays the same. When I look at 2 and 4, if I look at the number 2 and the number 4, both 2 and 4 share a common factor of 2. So that's the numerical side of greatest common factor. But when I look at the variable x's, here I have 1x, x to the first power, and here I have x squared. So the first function has 1x, while the second element, or second term, has 2 x's. And whenever I have x squared, that's really like x times x. So here I have 1x, here I have 2 x's. How many x's, greatest common factor, how many x's do they have in common? So they have 1x here, and there's 1x here. So they have 1x in common. So the greatest common factor of 2x and 4x squared is 2x. Looking at number 5, we're going through that same process. 10 and 15, since they're both divisible by 5, and they break down into 5 and 2 versus 5 and 3, I know 5 has to be my greatest common factor when it comes to my coefficient. So 5 is the numerical side. Then I look at the x's. How many x's do I have here? I have 3. How many x's do I have here? I have 2. So if I have 3 over here and 2 over here, how many do I have in common? I have 2 that are in common. So 5x squared is my greatest common factor. Number 6 is a little more challenging, and at any time throughout the video, if you feel like you're getting a hang of this, you can always pause the video, try some problems ahead of me, and then catch up as you go through it. 12 and 18. 12 is going to break down into 4 and 3. It also can break down into 6 and 2. 18 breaks down into 9 and 2, but it also breaks down into 6 and 3. So when I look at these numbers, obviously my numerical GCF is going to be 6, since those are the two largest numbers they share. And then when I look at the x's, here I have 2x squares and I have 1x. So 2x's and 1x, how many do they have in common? They have 1x in common. Here I have 1y, and here I have 2y's. So how many y's do I have in common? I have 1y in common. Another way I've heard this for students that might benefit you a little bit better, if you look at variables, as long as they have the same variable or the same base, whoever has the lower exponent, that's the amount you write down. So when I had 2x's and I had an x, I wrote down 1x because that had the lower degree, or lower exponent number. Y and y squared, only 1y, so I wrote that there as well. So 6xy is my greatest common factor of those two terms. Now when we start factoring, this important skill is going to be helpful, because what we'll do is we'll actually take a binomial expression like 8x minus 12 here, and we'll actually find the greatest common factor, monomial, which is a single term, and we'll be able to factor that out of each of the two terms in my binomial. So when I look at 8x, it has an 8 and has an x, and when I look at 12, since 8x has an x and 12 doesn't have an x, x is not a common factor that I could factor out of the binomial. But when I look at 8 breaks down into 4 and 2, or 8 and 1, obviously. 12 is going to break down into possible factors of 4 and 3, or 6 and 2, or 12 and 1. The greatest common factor that they share is 4. So 4 is my greatest common factor numerically. And everything else in the two terms is not a common factor. It's going to stay right where it is in the binomial. So what I'm going to do first here is I'm going to think about, okay, the x had no partner to go with, so he's going to stay right where he is. He's not going to come out of the equation. However, when I took 8 and I broke it down, its multiple into two factors, 4 and 2, when I took out the 4 is taken out of 8. What's left is a positive 2. So I'm going to write that 2 right there next to the x. When I took the 4 out of the 12, what was left was a positive 3, and that's what's going to go in that spot as well. So after I factored out my monomial, I get 4 times the quantity 2x minus 3. Let's try a couple more together, and then you can try some of the ones at the bottom on your own, and then check it with the key that will be posted online. So 15x squared plus 20x. When I look at 15, 15 breaks down into 3 and 5. 20 breaks down into 2 and 10, 20 and 1, which are all great, but the greatest common factor here will most likely be, and will be, 4 and 5. So my GCF is going to be that 5, and I'm going to take out of both. Now I also have to look at the x's, because x's are in both terms. So here I have x squared, here I have an x. There are more x's with the 15, there's fewer x's with the 20. Whoever has fewer, that guy is going to come along as a GCF. So once I take a 5x out, what's left over in this sum of 15x squared minus 20x? So when I took out the 5, the only factor I was left with was a 3. So 15 becomes a 3. And when I took out 1x, I had 2 x's. Let's think about this for a second. I had x times x. I took one of the x's away, and I pulled it outside. So after I did that, what I was left with is a single x. 20, took out the 5, and all I was left with was a 4. And since there was one x, but I pulled that x out in front as a factor, there's no x left over next to the 4. We're going to try 2 more here. We're going to speed it up a little bit, and then as you're going through these practice problems, make sure that you revisit the video at any one time if you're confused about a certain problem to clarify. Variables don't always have to be x's and y's. Sometimes they could be variables like n or a or b or m. So here's an example where I have two variables of n. Since they're the same variable, I can factor out a common factor. So first I'm going to look at the numbers. 6 breaks down to 2 times 3. 15 breaks down to 3 times 5. Since 2 and 5 don't share any other factors, 3 is my greatest common factor. And I'm also going to look at the variables. Here I have n squared, so I have 2 n's here. Here I have 1 n. So since they only have 1 n in common, that's what's going to come out in front. Now what's left over? After I took away the 3, all I was left with was a factor of 2 and an n that was still with that n squared. Minus, when I took away the 3 from 15, I was left with a 5. And when I took away the n, then I'm just left with a 5. Now you might be asking yourself, how do I know if I'm doing this right? Once you get your final answer, it's very easy to what we call distribute, okay, or expand, and actually multiply 3n times 2n to get 6n squared, and 3n times negative 5 to get negative 15n. When I distribute or expand and I get the exact same thing I started with, then I know I'm doing it correctly. Let's look at number 10 together here. 14 is going to break down into 2 times 7, and 8 breaks down into 2 times 4. Again, 7 is a prime number, so it doesn't have any other factors that match with the 4. So my greatest common factor here is 2. Now I look at the variables. I have an x squared right here, and I have a single x right here. So how many do they have in common? They have 1x in common, or the 1x that they share. Here I have 1y, and here I have y squared. There are fewer y's over here. There's only one of them, so that means this is going to be y. In parentheses is what's left over after I take out a factor of 2x and y. When I took out the 2, I was left with a factor of 7. When I took out one of the x's, I took out 1x right here, so this is gone. Now I'm just left with a single x. And when I took out the y, that y is now gone as well. When I took out the 2 here, I was left with a 4. So minus, same sign, 4. And what I'm left with my variables is I took out an x, so that x is gone. I took out a y, so when I had 2, I took away 1, so now I'm left with 1y left over. So that's just a quick mini lesson on factoring using greatest common factors. Go ahead and try these problems at the bottom, and hopefully that will give you some practice, and check them with the answer key that will be posted online as well. Thanks.